Multiplying integers is nothing new. You might not have used that terminology when you talked about multiplying integers, but when you multiply the numbers 2 times 3 together, you're multiplying integers. We know that 2 is an integer because it's a counting number, and we know that 3 is an integer because it's also a counting number. So when you multiply integers, 2 times 3 equals 6, you've already done this. But we're going to expand to other numbers like opposites in multiplication. But first, let's talk about a little bit of notation. So you're used to using this notation 2 times 3 to mean multiplication. The problem with this is as you get farther and farther into algebra, this time starts to look like an X. So we need another way to write it. And you've probably seen before the dot system, 2 times 3, which is exactly the same thing, only instead of a times or an X for a times or a cross, we're using a dot. Another way to write multiplication would be 2 times 3, where we know it's times or multiplication because we haven't put in a plus or a minus, but the problem with this is that it looks like it could be 23, the number 23. And so we're going to use a parenthesis to separate them so we know it's two numbers. And with no other operation written down, we assume it's multiplication. If it were 2 plus 3, that plus sign would tell us it's addition. But there isn't a plus sign in this problem. There's no operation written there, so we assume it's multiplication. And then sometimes while you're developing the skill, your textbook will mix it all up together. So you'll get something that looks like 4 times 2 times 3, like that. Maybe, and then add a times 2 again. So sometimes your textbook will mix it all up, and you have to just be careful to know that this is the times sign, and then this parenthesis just means I'm grouping a number there. Okay, so this is all just trying to get you familiar with the notation. So let's do a couple of examples, just to remind ourselves that we really do already know how to do this. Say I want to multiply 3 times 4. So you know your math facts from elementary school. You know that 3 times 4 equals 12. So that's just math facts. But let's talk about why does it equal 12. So it equals 12 because we're saying that we want a pile of 3 dots. I'm going to use dots in this case. A pile of 3 dots 4 times, which means I want 4 piles of 3 dots. So this would be one pile of 3 dots. Another pile. I'm having a hard time concentrating because these kind of look like funny faces to me. Let's see if I can pull it together. Another pile. 1, 2, 3. I want 4 piles of them. So I have 4 piles of 3 dots. So I have 3 dots taken 4 times. Count up the dots. Well, first off, I have 1, 2, 3, 4 piles of 3 dots. Count them up, and I get 12. Now, it works the other way around, interestingly enough, with multiplication. Suppose I had instead 4 dots in a pile, using this number for my piles. 4 dots in a pile, well this multiplication tells me I want to take 4 dots 3 times. 1, 2, 3. 4 times 3 is 12. So we're there. Oh, actually I shouldn't have done multiplication. That was a little break. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Done. Okay, let's do this other one, even though it's super duper ugly, just to see what happens. When you have a string of multiplications like this, it's really hard sometimes to just go straight across and do it and go problem by or number by number. So instead, you want to group it into smaller and smaller bits. So I'm going to do this in steps. First, I'm going to multiply the first 2 numbers together. I get 4 times 2 equals 8. Then I still have to multiply, bring everything else down. I still have to finish the rest of the problem, right? Well, now I can take 3 times 8, or 8 times 3, which is 24, but I still have to multiply that by 2. But now, this time, 24 times 2 equals 48. So whenever you get more than one integer in a multiplication string, there are no pluses or minuses, it's all multiplication, you just take a part of it at a time. So first part, second part, third part, until you end up at the answer that you're looking for. Now all of that is fine and good until you get to integers. Well, all of that is fine and good as long as it looks like your regular math facts. But what happens if I ask you to multiply 2 times -3? What now? So that means I'm going to take, well, piles of 2, and I want -3 of them. Well, how do you write negative anything? How do you write the opposite of negative? That's crazy. So I'm going to have to work in the opposite direction for this one. And I'm going to take piles of -3. Now we worked with algebra tiles today, and there's a reason for that, because negative numbers have an X on them, right? So that's a negative. I'm drawing circles because it's easier than squares, but that means I have a pile, one pile of -3s. Now I need a second pile of -3. Okay, so I have 1, 2, 3, and they have x's, so they're negative. 1, 2, 3, and they have x's, so they're negative. What do I have when I'm finished? I don't have anything that tells me that they're the opposite, right? Well, except that if I figured I started with a 3, then I put a cross sign to make it negative. I flipped it over. But other than that, nothing to tell us that we're changing anything. This is, how many do I have? I have -6, because I have 6 objects, but they're the opposite, right? They flipped. So I have -6. Let's look at another one of those. Let's look at, well, let's number that one first. 3. So now let's look at number 4. What if I wanted to multiply -2 times 2? So that means I want a -2, I want a pile of -2, but I want 2 piles of -2s. So 1, oh, I can't do the dot method because I need x's, right? So I have 1, 2 negatives. That's one pile. And now I need 1, 2 more negatives in a second pile. And how many negatives do I have? I have -4. So -2 times 2 equals -4. At this point we can make a rule. Even though we're going to work with algebra tiles and we think that's all great, we need to be able to do this without having to pull out the tiles too. So the rule, now remember, when we're adding and subtracting with negative numbers, if this had been 2 plus -3, we would go to the number line. So for the number line, or for adding and subtracting, we always deal with the number line. 2 plus -3. So here's 0. We jump on at 2, going the right direction. Plus says keep going the right direction. Minus says turn around the opposite direction. And 3 says bounce 3 times. So if I bounce 3 times, I would have to bounce twice to get to 0 and once more to get to -1. That's bouncing 3 times in the opposite direction. Notice I did that a little bit different. Instead of actually bouncing 2 times to 0, now that we've practiced that a bit, we're going to change it up. So let's do another one. Let's do -3 minus -4. Right? So this is all adding and subtracting. There's no multiplication here. So that means it's all on the number line. Adding and subtracting is all on the number line. Start at 0. I want to go straight to -3, heading the right direction. This minus says to turn around. This minus says to turn around again, or you can start to use your rule. 2 minuses means a plus, so we're going to keep going in the positive direction. And then I want to bounce 4 times. 3 of those bounces would take me to 0, and then there's only 1 more. So I'd be at 1. So this equals 1. Okay? All right. So that's when you're adding and subtracting with integers, whether they're positive or negative integers or addition and subtraction. But multiplication is different. Multiplying is a rule. You want to remember the rule. And the rule is when you multiply or divide, integers with negative values, meaning -2, -3, -7, those are integers. If you multiply with negative values, then every two negatives, or every time there are two negatives, ooh, turn them into a positive. They turn positive. Because remember, negatives just mean opposite, opposite. So two of them, opposite, you start at positive, you go opposite, and then opposite, you end up back where you started. Right? So two negatives here makes a positive. The same thing's true in your multiplication. So let me show you a couple of examples. Suppose I want to multiply -3 times -4. First step is just worry about the 3 and the 4. So you have a 3 times 4 equals 12. And then to decide if the answer is negative or positive, two negatives in a multiplication problem become a positive. So this would equal positive 12. Okay, another example. -3 times 2 times 2. So let's see. First, ignore the signs altogether because it's multiplication. There's no adding or subtracting here. It's multiplication. So I'm going to multiply 3 times 2, which is 6. I still have to keep the negative that came with the 3 times 2 because I don't have 2 in order to turn them into a positive. So it's still negative. There's no second negative to turn that into a positive. And then I have to bring down the 2 that I haven't multiplied yet. So 6 times 2, doing the same thing, ignoring first all the signs. 6 times 2 is 12. And then again, I still only have a 1 negative. I don't have an even number. I have an odd number of negatives. So the answer here would be -12. So for multiplication and division, multiply the integers first and then decide if it's going to be a positive or a negative problem. One more example just to be sure. -6 times 2 times -3. Okay, first two problems together. Ignore the signs, just go with the numbers. 6 times 2 is 12, and then decide for these first two problems, do I have a pair of negatives that can become a positive? And I do not. So I still have just the odd or the 1 negative. And then that's times the -3, which has to be still worked with. So 12 times 3, doing just the numbers first, 12 times 3 is 36. And then this time I do. Look, I have two negatives, which become a positive, so the answer is a positive 36. All right, now one last thing to consider, and that's sometimes you're going to be told to find this value. What does that mean? Well, some of you have seen exponents already and some have not. That's okay. I'm going to tell you. This little tiny number up here tells you that you want to multiply this number over and over and over that many times. So -2 squared says -2 times -2. -2 cubed says you want to multiply -2 times -2 times -2. 3 times. The same number over and over 3 times. -5 squared tells you to multiply the number -5 twice. Or 3 to the 4th power tells you to multiply 3 times 3 times 3 times 3, 4 times. So let's go ahead and do these real quick just to finish it up. Negative 2 times negative 2, if I do the integers first, I get 2 times 2, which is 4. 2 negatives become a positive, so the answer is a positive 4. Next one. Negative 2 times negative 2, well, we've already done that, right? Negative 2 times negative 2 is 4. So I'm going to make it a positive 4, but I still have to multiply by another negative 2. 4 times 2 is 8. I only have one minus sign, so I have to keep it. The next one, 5 times 5 is 25. 2 negatives make a positive, so the answer is 25. And the last one, well, this one doesn't have any negatives in it, so it's super easy. 3 times 3 is 9. I still have to multiply by 3 times 3 again, right? So there are 4 of them. Well, 9 times 3 is 27, and I still have to multiply by the fourth 3, and 27 times 3 is 81.